About a new type of factoring called sum and difference of cubes. Okay, and that's what we were working on Friday. Today we're going to do another type. All right. So, Alvin, can you read us the essential question, please? Perfect. All right, Sebastian, can you read us the I can statement?
I can factor a polynomial by grouping.
Perfect. Polynomial, remember we talked about on Friday, that means many. And so we're doing we've had polynomials all along. You guys already know how to do a lot with polynomials that we're not doing official lessons on. We had learned the multiplying with the boxes last week. I refuse. There's a lesson in your textbook on combining like terms. I refuse to teach that this year because I think you all are over that and know how to do that. It's silly to waste a day on it. We've got other things we can do. So we're doing this one and one more on polynomials, and then we're going to kind of get back into our radicals, rationals things. Okay. But I thought this was kind of a little bit of an icebreaker. It doesn't look like we did number 6, so let's do number 6 right now. Okay. Let's review our sum and difference of cubes. Is that right? We didn't do number 6? Okay. Because I think that 4th period I didn't end up teaching the lesson. They were freaking out other ways. Okay, so with sum and difference of cubes, just to refresh our memory, we have to cube root, or we do the signs first. We have to decide if it's plus or minus first, and then we do our sign pattern. So the sign pattern is either plus, or minus, plus. And then we're going to do cubed root, square it, and multiply in the middle, right? And we also have to always start with, remember, we have to start with and look and make sure we've got a greatest common factor, and we count the number of terms to determine what kind of factoring we're going to use. Okay. So first thing I'm always going to ask myself is there a greatest common factor? Yes or no? Yeah, what is it? 2x squared. So it's definitely even, right? And then you want to pull out the lowest exponent usually. Okay. All right, remember factoring is just division, so I'm dividing each one of these terms now by 2x squared, which means we're going to end up subtracting our exponents. So what's 2x to the 5th divided by 2x squared when I pull it out? X cubed. Good. All right, what's 250x squared divided by 2x squared? 125. Now, every time you factor, remember, you need to look and see if there's more to be done. So I notice I have 2 terms. When I have 2 terms, I have to make a determination if I have a difference of squares or sum or difference of cubes or nothing, right? It could be nothing. All right, so are these square terms? Are those square numbers like we were just working with a few minutes ago? Are they cubes? Yeah, they're definitely on our cube list, right? So remember when we're factoring, we've got to make sure we drop the greatest common factor down. And then I'm going to split this into a binomial times a trinomial. And now I'm going to look at my signs. I always start with whatever sign I'm originally given. So I'm starting with plus. What are my other 2 signs going to have to be? Good. Minus, plus. All right, then we're going to cube root this term. What's the cubed root of x cubed? X. What's the cubed root of 125? 5. You can always look at, we wrote it in the left-hand column, right? All right. I'm going to square this. What do I get when I square that? X squared. What do I get when I square the 5? That goes in the back. And then I ignore the signs and I multiply for the middle. So what do I get in the middle? 5x. Okay, so that's a little refresher from Friday. Okay. All right, we're going to move on to the other type, which is factor by grouping. Okay. Which it's basically a fancy group greatest common factor. Okay. It's a fancy GCF method. Examples 7 and 8 are really the intermediate step. Okay. So if you'll notice, there's actually 2 sets of things here, right? There's this one, and there's that one, because there's a big minus sign in between it, but in between here we have multiplication. So out of the yellow group and the purple group, do you notice something that's the same? What's the same? Yeah, the x minus 5. Instead of it being a monomial greatest common factor, it's a binomial greatest common factor. Whenever we do greatest common factors, we take it and we write it out front. How many times do I actually write that down? Yeah, we write it down one time, right? When we did this, when we took that out, we only wrote it down one time, didn't we? So whenever you see this greatest common factor come out, you're going to write it once. Okay? And then you'll notice I had 3x squared minus 2 left behind. So 3x squared minus 2. And that's it. Well, not always. Sometimes this will go more. Sometimes there'll be like a difference of squares there or a difference of cubes or something, but you want to check it. But if that in this case, it doesn't work because we've got a 3 and a 2. Those are not squares. Okay? All right, I want you to try a 8. See if you can figure out the ugly greatest common factor that's going to go out front and write it down one time and then write down what remains. So everybody just try it on your own once. Okay, let's take a look. All right, what is the same in both my yellow group and my purple group? X plus 2. And it's going to be a binomial. That's on purpose, okay? So it's an uglier looking greatest common factor. I'm going to bring that out front because it's just a greatest common factor. How many times am I allowed to write that down? Once. Okay. And then what was left behind was this 4x squared and 3. So 4x squared plus 3. And there's nothing else I can do to factor that back piece. All right, so that's not what the problems are truly going to look like. That was getting you to understand the middle step. Okay, so we kind of started in the middle. The problems are going to actually look like what's 9, 10, 11, 12. So remember our line of we're supposed to look for greatest common factor first, and then we're supposed to count the number of terms. If you have 4 terms, you're likely grouping. Okay. All right. So first thing I'm going to look at, is there a greatest common factor that divides all 4 of those things? No. Okay, so now I'm going to count the terms. 1, 2, 3, 4. My red lights go off. I must be grouping. Okay. Now, I do this weird. Okay. I know that you're following my method if I see you doing this. Okay. I don't write parentheses because you're not multiplying those things together. But sometimes it helps to have something in there that helps us split it in our brain into 2 different sets of things that we can factor. Okay. So what I do is I draw the least mathematical symbol ever, a squiggly line. Okay. And notice I draw it in between the term and the sign. Okay. So all this is like a lot of greatest common factor. Okay. So I'm going to take the greatest common factor out of this first term. Okay. So what is the greatest common factor in just these first 2? 2x squared. Good. All right. And then I got to figure out what's left behind in just these first 2. So when I divide 2x squared into x cubed, what's left behind? X, and then minus 3 for the 6x squared part. Okay. In this second group, what is the greatest common factor? If there's a negative there, pull it out. Okay, so if it leads with a negative right in there, pull out that negative. So negative 5. And then I'm going to divide by the negative 5, right? What's left behind? That looks kind of familiar, doesn't it? So what we did was we built this thing that we had up here in example 7 and 8. We made it on our own. Okay. So do you notice in the purpley group and the green group what matches? X minus 3 is the same. That's our ugly greatest common factor. I'm going to bring it out front. How many times am I allowed to write it down? Once. So x minus 3. And then left behind is this 2x squared minus 5. So I'm just writing that exactly the way it looks. 2x squared minus 5. Okay. We're going to try it again together. Okay. I'm trying to think about what I had written here. All right. So is there a greatest common factor that divides all 4 terms? No. Okay. How many terms are there? 4. So I know I'm going to do greatest common factor. Mrs. Ballard draws this weird squiggly line. So my brain sees the first half and the second half separately. Okay. All right. What is the greatest common factor in this first group? 4x squared. Good. All right. Then what's left behind when I pull out the 4x squared? Everybody good with x plus 6? Okay. All right. The second group, remember, if I lead with a negative, I want to pull it out. What's my greatest common factor in my second group? Good. And when I pull out the -3, what's left behind? Ooh, what do you know? That looks familiar, right? It should be the same. If it's not on a quiz, either I messed up really big and everybody's hand in the room should be going up, right? Or you messed up big. So if you don't see everyone's hand going up, then it's probably, but you have to be the brave first one to put your hand up, right? I check them pretty good, so it shouldn't happen, but it's so likely they're going to be the same. Okay. All right. So what's my ugly greatest common factor here? X plus 6. How many times do I write that when I write it out front? Once. And then left behind is 4x squared minus 3. Okay. I'm going to have you start. We're going to do a little bit more on our own this time. Okay. So what I want you to do is we're going to split it here, right? We look for our greatest common factor. There isn't one. We know we've got 4 terms. We know we've got to do grouping. So I'm going to split it. I want you to just do the step where you pull the greatest common factor out of the first one and the greatest common factor out of the second one. Don't go any further than that. So just the greatest first greatest common factor out. Make sure you're trying it. This is your opportunity. Careful with my algebra. Okay. Let's take a look at just that part. So what was your greatest common factor in just this first group? 3x squared. What was left behind? 2x plus 1. Okay. In the second group, what was your greatest common factor? Good. What was left behind? Good. All right. If you haven't done it yet, I want you to take like 30 seconds. I want you to find your ugly greatest common factor, put it out front, write it once, right? And then write down what's left over. So everybody try that next line. Okay. What's our ugly greatest common factor? What matches? 2x plus 1. Okay. I'm going to take that out. How many times do I write it down? Once. Okay. And then left behind is 3x squared minus 4. Okay. I want you to try example 12 from beginning to end on your own. Okay. Beginning to end on your own, for example. Don't go to 13 and 14 yet. They have other weird things that happen. Okay. Give you about 30 seconds on your own. Okay. I want you to take a minute and talk about it with your table partner, somebody your table partner's absent. Okay. See how you're doing. Compare your answers. Have a conversation, please. Uh-oh, looks like I messed up, didn't I? All right. Did anybody pull a greatest common factor out to begin with? We all forgot that part, huh? All right. So in theory, there should have been the greatest common factor come out at the beginning, but that's okay. We're gonna pull it. We're gonna do the different or the grouping on it. So what's your greatest common factor in the first group? 10x cubed, right? Okay. Then let's see what was left behind. 2x minus 1. Okay, and then what's your greatest common factor in the second group? 2x, what's left behind? Good. So what matched? 2x minus 1 is that ugly greatest common factor. We're going to write it down out front how many times? Once. So 2x minus 1. All right, and then what was left behind? 10x cubed plus 2x. Now, technically, and we hadn't seen this happen yet before, there's more to go there, isn't there? Because isn't there a greatest common factor hiding in there? What's the greatest common factor that's hiding in that back piece? There's a 2x hiding in there. Okay, so I'm just going to drop the 2x minus 1. I'm not changing that. I'm going to pull out a 2x out of it, which I'm going to float in front. How many times does 2x divide 10x cubed? 5x squared, right? How many times does 2x divide 2x? 1. If you got this line here, you got the intent of the lesson, right? The intent was grouping. That was Mrs. Ballard messed up the problem, and that's why there was an extra GCF in there. That was not my intent. Sorry. It happens once in a while. All right. We good with 12? All right. We're going to do, that kind of leads into what the next two look like, though, because we have to go a little bit further in the next two, because whenever we factor, we have to factor completely. Okay. So looking at this next one, I'm looking at it. Oh, it's going to do kind of the same thing. It's not going to do what I want it to do. X to the fourth. Oh, no, it might be okay. All right, so well, I don't know what I was thinking when I made them up. Apparently, I wasn't. All right, let's look at 13. Let's see if I can do it the correct way the first time up. So first question we're supposed to ask ourselves is there a greatest common factor? What is it? Looks like 4 what? 4x squared. Okay, so let's try pulling that out and see what happens. So 4x squared comes out. Let's see. So that gives me 2x cubed plus, let's see, 4x squared. Make sure I'm on the right track. Minus 3x minus 6. Did I do that right? Everybody good? Okay. There's nothing else that divides all three. How many terms do I have left in the parentheses? 4. Okay, so what kind of factoring am I supposed to use? What's our new one called? Grouping. Okay, so I'm going to put my little squiggle in there. Just like we had before, we're going to drop that 4x squared down. Okay, I'm going to have a binomial probably times some. Oh, wait, not yet. I'm going to keep it in parentheses. All right, what are we going to take out of this first group here? What's the greatest common factor in this group? 2x squared. Okay. When I divide the 2x squared, what's left behind? X plus 2. Good. Okay, looking at the second group, what am I going to be able to take out? Say it again louder. -3. Good. What's left behind? X plus 2. What do you know? It matches, right? It's like a big surprise every time. All right. I'm going to still drop my 4x squared. Okay. And keep my parentheses for now. I am going to write down what matches. What matches? How many times do I write it? Once. So x plus 2. And then I write down everything else that's left behind, which is the 2x squared minus 3. And then in theory, I should check it to see if anything else works. I don't think it does. Don't really need those big blue parentheses. I really don't need them because it was all just multiplying. So that's why I erased them. If you have them, it's not wrong. Okay. Example 14 was what I was hoping I was getting at sooner, but that's okay. So looking at 14, is there a greatest common factor in all 4 terms? No. Okay. So what kind of, I already said 4 terms. If we have 4 terms, what kind of factoring? Grouping. So I am splitting here. Okay. All right. In my first group, what's going to come out? Good. What's left behind? X minus 1. Everybody good with x minus 1? Okay. In my second group, what am I going to divide? What's my greatest common factor? Just 9? Negative 9. Good. What's left behind? Good. I'm dividing by a negative 9. Dividing by negative 9, I get x minus 1 left. What matches in both groups? Good. How many times do we write it out front? Once. Good. And then I write down everything that's left, which happens to be x squared minus 9. Hopefully we're really good enough at factoring. What kind of factoring is this back here? Yeah, there's a difference of squares. You see how that popped in there? So you drop the x minus 1, it doesn't change, and we do a difference of squares back here. Square root of x squared is x, square root of 9 is 3, like 1 a plus, 1 a minus. Okay? All right, that's what we have for today. You have about 10, 11 minutes left. Okay, so remember that on your weekly guide, okay, or your unit guide, which is posted in Google Classroom, right? I may not have updated this week or maybe even last week, but it should be under whatever the week before was. The Friday and the Tuesday are exactly the same. It's not a new homework assignment. It's a homework for that section. If you click on it, it's in Delta Math. If you aren't in my Delta Math, if you scroll down, I put my code there. Also, if you haven't joined my Remind class, I send reminders out on that, especially to remind you to study for tests and things. So you might want to join that if you're newer to the class, okay? But you've got a few minutes left. I would get in here and I'd be practicing that Delta Math, okay?